And I think everyone have a copy of the notes. So phone should be away, copy of the notes is on the desk. Here we go. So, a few things for this week, just a note. Friday we will have our next unit test. So Thursday we will give out the take-home test. And the take-home test, remember, it counts as scores. So if you just put arbitrary numbers in, you're going to miss it. Unless you have really luck on your side and you are able to guess random numbers appropriately. Okay, so solving compound inequality. So this is a little deeper. This is where we're going to start putting two types of inequalities together. We've kind of seen this a little bit where we were talking about the temperatures of ovens and things like that, or team scores or anything like that. But this goes a little bit further, and we start using some vocabulary. So let's talk about this. There's a lab that sometimes is done where you heat and you take electricity, and you can have it looks like your pennies turn into gold because zinc is adhering to it. And it's a process where you heat it up and you also run electricity through it, and the ions from the zinc go over onto the copper of the penny, and then it does appear to be a gold penny. Is it really gold? No, you're not changing the atomic structure of copper to the atomic structure of gold. You're not changing elements. But it's a neat little trick to do. But if you allow your temperature to get too warm, the zinc is going to burn and the penny will turn black. Okay? So let's think about this. I want to have my temperature, my penny, I want it to be above 270 degrees Celsius. You remember Celsius and Fahrenheit, they're just two different ways of measuring. But I also want it below a certain temperature of 295 Celsius so you can get the right effect. So does temperature have something to do with this problem? Yeah. And if you didn't follow the directions, and let's face it, times if you're working in the lab, a lot of times kids will say, oh, let's see how high this flame will go, and if it gets higher and higher and higher, the temperature obviously will rise. But so this is kind of a compound inequality as we're thinking, where P in this case is going to represent the penny. It's not vital that I have Celsius in there, but I want to think about how I can put these together. So let's reread it, make sure it's okay. Some of you have done a science lab where you turned pennies to gold. Again, I just said you're not actually changing the copper, the element copper, into the element gold. It's just it appears that it turns to gold. Excuse me. In order to get the penny to turn from gold after plating it with zinc, the temperature must reach at least 270 degrees. Okay, so at least, are you including it? Yeah. So we have an equal sign. If the temperature goes above 295 degrees, so above 295, so I think we're including that as well. Above 295, however, the zinc will burn and the penny will turn black. How can you tell the science class what temperature will work? So does everyone feel appropriate that we have a range of temperatures that this experiment would work in between? That make sense? So what is my lowest number that I'm dealing with as far as temperatures to make this work? 270? Everyone feel okay with that?
Yeah.
Now I'm going to go as less than or equal to P. What's my highest temperature? 295. Okay, so this whole thing together, so this means that my temperature can be at 270 all the way to 295 or whatever's in between, and we would still get the reaction to be appropriate, and our penny would turn to the gold color and then not the black color. Okay? So again, you're not changing, this is not a way to manipulate copper to gold. If it was, we probably wouldn't be teaching it, we'd be a lot richer because the cost of copper is a lot less than the cost of gold. May I move to the next screen? So this is a compound inequality. Copper is an inexpensive metal. It is. All right, so we're going to look at the two words and or. So on a number line, if I had 2 points and I shade in between those two, this refers to a graph being and. Okay, they're come together. If I had a number line such as this, where I have 2 solid dots, or one open, one closed, or both open, doesn't matter, and I'm shading away from each point, and I'm not including the center region, this refers to an OR graph. So these values both work, and these values you're going opposite, so you're not including the center, so it's called an OR. This or this works.
What happens if they go the same way? Like one goes to the left and the other goes to the right.
It's going to be an and situation. There are times that they could have the problem set up to where everything's going to work, and that's just all real solutions, or all real numbers, or infinite solutions, or something like that. Are we okay so far with that? That good? Moving forward. All right, so give each as an inequality and give it in interval notation. Okay, so let's take a look at just this portion right there. Where is that portion coming from? Negative what? Where's it coming? I heard it. It's not negative 2. It's not coming from negative infinity. It's coming from negative infinity, which is over here, and it's going to negative 2. So this is going from negative infinity all the way up to negative 2. Am I going to include the negative 2 or not? Is it a solid dot at the negative 2 or an open dot? Open dot, so we're not going to include it. Okay? So that's that region over there. What is this region right here going to do? Where's it starting from? 3. Am I including it?
Yes.
It's open or closed dot?
Open.
So is it included?
No.
No. Where's it going?
Infinity.
Okay? Now, I had said one slide back, does that look like an AND graph or an OR graph?
Or.
It's OR. Okay, it's shading away. So for right now, we're just going to put OR. So our graph that's represented up here goes from negative infinity up to negative 2. Does not include negative 2, but it goes up to it real close. Or it goes from 3 to infinity. And we know it's OR because it's shading away from each other. It's not coming together. We don't have an overlap of the shading. What does graph number 2 look like? Is it an AND or an OR? And you have 2 endpoints that, and in between you're shading them. So you could say that, you could say 2 different things. You could say x is greater than negative 2 and x is less than 3. So this graph would go from negative 2 to 3. And there's our endpoints. Why are they both parentheses here and here?
Because they're not equal.
Yeah, we're not equal to them. It's an open dot. Okay? Now, graph 3 appears to be the same exact thing as graph 2, but something's different about the endpoints. What's different? Are they solid dots or open? Yeah. So did you get done? Sweet. Yeah, baby. They are solid dots, and they will continue to be solid. So this one, because we have this, that means I have x is greater than or equal to negative 2. Because I have that, x is less than or equal to 3. If I were to make this as an interval notation, I have square brackets from negative 2 to 3. The reason it's square brackets is I'm including the endpoints. Seem okay so far? Do you see a difference between the second and the third graph? The second and the third graph, we would say it's an and property. And refers to that you're shading in between 2 points, or means you're shading away from 2 points. Okay? Do either of these two graphs go to negative or positive infinity?
No.
They're bound. So that would mean something, right? May I move to the next screen?
Yes.
All right, so you have compound inequalities, and solving compound and inequalities, solve two at the same time, solve the following, give the answers in interval notation. Okay, so a little hint, when we have problems like this put together, that means we're gonna shade the endpoints. We don't put or problems together like this. We actually write the word or in between them. So these are supposed to be both and problems. If they're both and problems, you'll have endpoints, and we'll shade in between the two. So you treat this as two problems. Your first problem is this. Your second problem is this. What went with each problem?
The signs.
Signs. What else? X. So this middle part here goes with both. So 2x plus 4 goes here, and 2x plus 4 goes here. And we just solve each of those just like a traditional problem. I like to keep things as we had written them. So that's going to be negative 16 is less than or equal to 2x. And then the second problem. So negative 8 is greater than x, or equal to x, and then x is less than. So what this number line looks like, I'll draw it down below a little bit. This number line looks like this. I got negative 8 here, I got 0 here, I got 8 here. Is it a solid or open dot at negative 8? Solid? It's solid because it's equal to. Is it a solid or an open dot at 8? Open. I'm going to shade in between the two. Okay, remember, and you shade in between the two.
So it doesn't really matter what the inequality signs are, right? You just shade them too.
And the reason it works is if I put this back together, it's going to look like this, where I combine these in there. Okay, so which means this. I'm going to go from negative 8, square bracket, to 8, rounded bracket. And there's our, that's our interval notation of it. That just means what are my endpoints? Where are we at? That's all we do. Make sense so far? Compound inequalities, we're putting them back together. We're talking about those. Can I try the second problem? I'm still taking notes there. All right, second problem. What part of this problem is going to go with the two problems? Will the 18 go with both parts? Will the middle part, or will the 24 go with both parts? What do you think? What one with both parts on that first problem? The ends or the middle?
Middle.
Middle. You think it's going to change? No, it's going to stay the same. So this middle, we're going to write two problems out. So my first problem is going to be 18 is less than 2 quantity 3x plus 9. My other problem is 2 quantity 3x plus 9 less than or equal to 24. Squeeze it up there, okay? Oh, man, darn projector. distribute here. And subtract 18. That's my first problem. Second problem, again, distribute over. Subtract 18. Divide by 6. If I put this compound inequality back together, notice where the x is in relation. So I have 0 is less than x, which is less than or equal to 1. Which means on a number line, I have 0, I have 1. Open or close dot at 0. Open or close dot at 1.
Close.
Shade in between the two. The reason we know that is because and problems always are put together. So our interval notation is going to be a rounded bracket at 0, going to 1. What's my last symbol? Square or rounded? Square, because I include it. That's my interval notation. So IN for interval notation. What do you think? You get it all? Yeah, but. What do you think? Life good? So and, they come together. They can be square rounded brackets, they can both be square, they can both be rounded, they can be one of each. Square means we include that endpoint, it's a solid dot on the number line. Rounded means it's an open dot, we don't include it. We get real close to it, but we don't get to it. May I move to the next slide?
Yes.
Thank you. Does anyone know what kind of problems these would be? What kind of sticks out up there as a vital two-letter word? Or means we're shading together or apart from each other. Apart, right? Okay, so we're going to solve each of these problems and we'll put them on number lines so we can take a look at it. So what's the first step? I subtract 4 from both sides here. I get 2x is less than or equal to 16. Divided by 2, x is less than or equal to 8. Feel okay about that? Now I'm going to distribute here, so I'm going to get 6x plus 18 is greater than 78. Subtract 18 from both sides. 60 divided each side by 6, so I find that x is greater than 10. Okay, I cannot put these back together. These started as an or. The only way you can put these back together is write the word or in between the two. So I want values that are greater than 8, or excuse me, less than 8. And I want values that are greater than 10. Values that are less than 8, greater than 10. So let's think about on a number line what that's going to look like. Get it? Next one. So if I had 0 down here, and I had 8 about here, and I had 10 about here. Okay, so I want values that are less than or equal to 8. So what values are less than or equal to 8? 7, 6, 5, 4, 3, 2, 1, 0, negatives all the way. So that's going this way. And that's what that looks like on the number line. Open or close dot at 10. And I want values bigger than 10. So do I shade to the right or to the left? So values bigger than 10 are 11, 12, 13, 14, all the way to infinity. We know this is an OR problem because I'm shading opposite. So where is the green line coming from? Good. Where's the red line going to? Infinity. It's an infinity sign if I can draw it. All right, so this one here represents negative infinity up to what point? Negative infinity up to what point? 8 square or rounded bracket? Square because it's included. The word or, still with me? It started with a or, it's got to end with or. Am I going to do a rounded bracket at 10 or a square bracket at 10? Round. Where am I going to go? To infinity, and infinity always has the rounded bracket. So that's how you write this compound inequality in interval notation. Notice it started with the word or, it ends with the word or. If we had and in there, we can put it back together. You can't put a compound inequality back together. Okay, problem number 4. What's the error that people might make on this problem?
Subtract.
They might do that subtraction first rather than distribute the -2. Good. Everyone over there? Okay, let's combine like terms. So that and that. So I'm going to get 4 minus 2x is greater than 16. Subtract 4. -2x is greater than 12. What am I dividing by?
-2.
-2. So what does that do to the sign?
Changes it to a negative.
Changes the sign. That becomes a -6. What does this sign do?
It flips.
Flips. You good so far? All right, second problem. So looks like I could add 5 to both sides, right? What do you think? What's next?
Divide by 3.
Divide by 3? So here are my 2. If I want to put them back together, just normal, I put the word or in there. Let's think about on a number line what this looks like. If I had -6 here, 0 here, and I had 7 here. What am I doing at -6? Is it an open dot or a closed dot? Open. I want values that are less than -6. So what are things that are less than -6? -7 to all the way -infinity. We flip the sign because it's going to work. What about this one? Is it open, closed dot? Open at 7. Where am I going? 8, 9, 10, 11, 12, all the way to infinity. Okay, so that's coming from -infinity. That's going to infinity. Come on, extend. All right, so let's make the compound inequality. Where am I coming from on this right here? -infinity. I'm going all the way up to what? No, I'm going up to what? -6. Rounded or closed? Rounded or rounded square. I'm going to use the word or. Where's this net one now going? Positive 7 to positive infinity. Rounded. There's your compound inequality. So you have 2 problems that you are making happen with 1. Questions? May I move on to the last slide? I don't think there's anything on 8. No, that's right. All right. Use a graph to simplify the 2 inequalities. Give the answer in interval notation. Okay. Well, this is kind of weird. So I have 2, there's 0, and 5. So I want values that are bigger than 5. I want values that are bigger than 2. Ew. I'm going to put a question mark with that one. because it looks like an or, but they said the word and in there. So there's something goofy about that problem. Remember, or, I'm going out this way, and I'm going in between. So this appears that it's going to be an and, but how this is shaping, it's appearing to be an or. So this and that have to work. So let's pick a test point that might work. So what if I were to pick the point 6? Is 6 greater than 5?
Yes.
Okay. Is 6 greater than 2?
Yes.
Okay, so they both have to be true. So that's pretty good. Let's pick a value here. Pick like 3. Is 3 greater than 5? No. Is 3 greater than 2?
Yes.
But it's an and. They both have to work. So our solution to this problem cannot include this region. It can include this region here. So I'm going to go from 5, rounded bracket, to infinity. I can't go and include the 3 and the 4 because the 3 and the 4 don't work on part of the problem. You have to find where the region will work. I think problem number 2 is going to be a similar kind of goofy scenario. Okay, so if I had 4 here, I had negative 2 here, and there's 0 here. I have 4 going this way. I have negative 2 going this way. But there's a key word in there. Or. This problem or this problem works. This or this works. Not this and this works. So that's a key. This or means a lot. So if I were to pick, do what we did up here, if I were to pick 0, does 0 work on one of our problems? Is 0 less than 4? Yep. Is 0 less than negative 2? No. Only one of them has to work. This or this has to work. So our problem here is going to go from negative infinity all the way up to 4 rounded bracket. Because anything shaded over here will work on one of the 2 problems. And because it's an or, that's all it has to work with. And up on top, we couldn't include the shaded region between the 2 because this is the only region that works for both of these problems. Even though I had the shaded region, the overlap, it's an or scenario, so one or the other will work, or one region or the other. Let's look at number 3. Let's do it over here. So I have 6, there's 0 down here, 12. So I have a rounded dot going this way. I have a solid dot going this way. So I have values that are bigger than 6 and values that are less than 12. Do we satisfy that? Solid dot at the 12. So our interval notation here is going to be rounded bracket 6 to 12 square bracket. Remember, and comes together. If I were to pick 7, which is in there, 7 is greater than 6, 7 is less than 12, so our shaded region works. Problem number 4, we have an or scenario taking place. So that one's going that way. Ooh, that's a tough one. So I want values that are greater than or equal to 2 or values that are less than 7. So if I pick something in between, like if I picked 5, is 5 greater than 2? Is 5 less than 7? It works there. It works on both. One or the other has to work. In this case, both work. What if I pick, like, say, 100 way out here? Is 100 greater than 2?
Yes.
Yeah? Is 100 less than 7? But 100 works on one of them or the other. What if I picked like negative 100? Negative 100 is greater than negative 2? Nope. Negative 100 is less than 7? Yeah. Or works. So this is going to include everything this way and everything this way. So what solution set do you have? This one here, because you have the or, it's going to be all real numbers. Or in your guys' lingo, all real hashtags. Yeah, it's an infinite region. Everything can work. Yeah, I'd take that, yeah. Okay, the key on that one is the word or. The and is where it starts getting goofy. Because if it's an or, you only need one of them to work. If both work, great. If only one works, oh well. So we have the word and. So let's think about what this one's going to look like. I have 0, and I have -4. We want and, so I want values that are bigger than this, and I want values that are smaller than this. What kind of graph does this appear to be right now? It appears to be an OR graph. Okay? I can't pick a number over here. I couldn't pick like the number 5 and it works on both of them. Or I couldn't pick the number -10 and it works on both of them. I can't pick a number in between them and it works on both of them. So what would the answer be on this problem? No solution. And the reason it's no solution is the word and. You have to find something that works on both. So there's a no solution on that problem.
What if it was like 8?
Do I?
What if 0 was an 8? Same thing.
So x is greater than 8. You would have probably the region in B. No? Because they're shading opposite ways, it's going to get goofy. So you really should take those test points. So remember, if it's an and, if you pick a test point, it has to work excuse me, on both of them. If it's an or, it only has to work on one of them. That's the big key. Okay? Does somebody have your math book? You have your math book with you? All right, so your assignment for next time is pages 41, 42. And you have a little bit of time, so you can get a little bit of a start on it. My big thing for you to remember, or only one region needs to work. If it's and, both regions.